these are the notes for Unit 7, Day 6. And if we just read the introduction here, it says Miss Gallus's neighbor, Polynomial, is learning about multiplication and division in her 4th grade class. She is stuck on her homework problems and needs some help. After helping Polly with her homework, Miss Gallus wonders how the multiplication and division that Polly's learning in 4th grade relates to the polynomials she's teaching in her class. So if we look at question 1 here, this is Polly, this is our 4th grade student, and if you remember way back to that time of your life, we would do something like 7,160 divided by 5, right? And then we would start this long, messy process called long division. So we would say, okay, well, 5 goes into 7 once, and 1 times 5 is 5. We put the 5 down here, right? Remember this? And what we're really putting down there is 5,000. This 1 up here really, because it's above the 7, it stands for 1,000. This 5 stands for 5,000. So really what we're doing is we're taking 5,000 off of that total. And then we bring down the 1, and we start the process all over again. 5 goes into 21 4 times. 4 times 5 is 20. Really what we're saying there is 2,100, and then this is 400, right, because it's above the 100 spot. So we're really talking 2,000 here. 21,000, take away 2,000. So that's really 1. And then we bring the 6 down, and then we start the process all over again. It goes in 3 times. That's really 160. The 15 is really 150. We have 10 left over. Bring down the 0. 5 goes into 10 2 times. So we know then 5 goes into 7,165 times. And so we could write this as a multiplication problem. 5 times 1,432, right? And that would get us our 7,160 back. Okay, so let's see if 5 goes in again, right? Here, look at this here. We've got 1,432 again, right? So we're seeing if 5 goes in again to that. Oh, no, we're not. My mistake. We're doing exactly, I should read better. Let's get rid of that. Get rid of these yellow lines, get rid of these yellow lines. What we're doing is this, right? Just like I said. And so the multiplication problem is that, and that gets us our 7,160 back. Doesn't matter how much we write it, or which order we write it in. Okay, so how are these problems related? Well, they're inverse operations. Right? This is division. This is multiplication. One undoes the other. So that we would call those inverse operations. And so what we have is let me move that multiplication off to the side here. We have found these, let me change color, this 5 and this 1,432 are then factors. Getting into our math vocabulary here, factors. And factors are numbers that we multiply together to get a product. All right, so I'm really going to rely on that math vocabulary. Factors multiply together to make a product. So let's talk about this then. Let's go back to the teacher's perspective here. This teacher's a high school teacher. She's wondering how this multiplication and division works with polynomials. So because we know we can factor polynomials, right? We do a star method or whatever. And so how does this relate? Well, if we look in question 2 here, we have a factor times a factor. And we know these are factors. This sounds a little silly, but we know these are factors because they're being multiplied together, right? In between these brackets here is a multiplication sign. So we can call them factors because we're being multiplied together. So when we multiply these together, we get a product. Okay, and so we're going to multiply those together. Now you could claw this out, right? You could do a claw, 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 but I'm really going to expect you to rely on that area model that we do from time to time, because that area model is going to come back starting in this section, and it's going to make what is a difficult process much simpler. It's just a really effective way to organize what's going on when we talk about factors and products. So so we have 2x plus 1 as one factor, and x squared plus 4x minus 3 as another factor. All right, so these are the factors, and we're going to multiply those together. Okay, so in other words, everything in this box here is a product, part of the product. So 2x times x squared is 2x cubed. 2x times 4x is 8x squared. 2x times negative 3 is negative 6x. And if you notice, that would be the top claw. So if, let me delete this. Yeah, let me delete this. Right, we just did 2x times x squared and 2x times 4x and 2x times negative 3. So we just did the top claw. Now we're going to do the bottom claw, right? We're going to take that 1 and multiply it by every term in the other factor. So if I just give myself a little more space here, we are going to take 1 times x squared, 1 times 4x, and 1 times negative 3. So 1 times x squared is x squared. 1 times 4x is 4x. 1 times negative 3 is negative 3. And that is our product. So maybe I should have done a little color coding here. Let's call this the product. I'm going to call it blue. And then I'm going to come back in here and change the multiplication grid back to red. There we go. Oops. Let's try that again. There you go. Okay. So the product then, and this is where this this multiplication grid is really effective, because when we do multiply in this fashion, what we have is we have our like terms on the diagonal. So these are the terms that we're going to need to combine. So our product then, and this is where the area model pays off. Our product then is, you're able to combine like terms much more easily than if we would have multiplied them out and written them in one line. So we have 2x cubed, and you know, I'm just going to add a little comment here. When we multiply 2x and x squared, we get a positive value, right? So all these are positives, even though I didn't put plus signs there. So we got 2x cubed plus 9x squared minus 2x minus 3. So there's our product. So take a look at the next question, and we're going to work this next question kind of like question 1b right here, right? If this is the product, and notice it's right here, then what is the product divided by 2x plus 1? So what is this divided by this? Well, it must be the other factor. So it must be x squared plus 4x minus 3. And we know this because we know that 2x plus 1 times that factor, x squared plus 4x minus 3, equals that product, 2x cubed plus 9x minus 9x squared, excuse me, minus 2x minus 3. So we know that this has to be the answer because it's one of the two factors we had to begin with. Okay, so as you might kind of guess, we are going to work with division using that area model and finding that missing factor. So we're going to start by doing kind of a fill in the blank here. So fill in the missing blanks. And this is kind of the game we play when we do division, is we fill in the missing blanks. So it says, what multiplication problem could we use in the diagram to solve? So we know that the product, we color code this. This is the product. Okay? And if we notice we have like terms, we're going to combine these like terms, and we're going to combine these like terms. So it says, what multiplication problem could we use the diagram to solve? So this is why we call it fill in the blank. We're trying to find that missing factor, right? Because we are trying to solve a multiplication problem. So we need to find the missing factor. So we have to play this game of x times what gives us 4x cubed. What's the missing factor there? Well, if I multiply that together, I need a 4, and I need one less power of x. So 4x squared times x is 4x cubed. So it's kind of like, it's kind of process of elimination, so to speak. So x times what is negative 5x squared? Well, that's going to be negative 5x, right? I'm going to need the negative 5, and I'm going to need one smaller power. And then what times x is 3x? Well, that's going to be plus 3. Okay, and then let's just check to make sure that the bottom row is correct. 1 times 4x squared is 4x squared. 1 times negative 5x is negative 5x. 1 times 3 is 3. So that missing factor is 4x squared minus 5x plus 3. So we know that if that's the missing factor, then this times x plus 1 equals what's inside the area model, which is 4x cubed. I gotta move that over a little bit. I'm gonna run out of space. Oops, hold on here. There we go. Hold on, let me, I've got some big time rearranging here that I want to do. Scoot that out of the way a little bit. That's a little bit better. Okay, so the product then is 4x cubed, and now I've got to combine these like terms, so minus x squared. And then I got to combine these terms, that's minus 2x. And then I got a plus 3. So there's the multiplication problem that we can write. Okay, this is what division problem could we use? Well, if we want to do a division problem, then we want to take the product and divide out one of the factors. So our division problem is going to look like 4x cubed, excuse me, minus x squared minus 2x plus 3, that's the product, equals, divided by one of the factors. I'm going to take the x plus 1, equals that missing factor, which is that 4x squared minus 5x plus 3. And I'm going to color code this because my factors have been red. and my products have been blue, so these both are factors. And this is a product. There we go. Okay, so it says use the rectangular diagram to find this. So this is kind of interesting because this is our product, which means it goes inside. This goes inside. And this is a factor, which means it goes outside. And so we are going to play this fill in the blank game again. So we know that 3x minus 2, that's a factor. That's got to go along the dimension of the model that has spots for two things. Okay, so the product needs to go inside. And we know that the first term, let's pick a different color, let's pick brown. We know that the first term and the last term have nothing to combine with. So that represents the first corner and the last corner. So I'm going to start out by putting 3x cubed here, okay? And I'm not going to put the 10 here, not quite yet, okay? I'll talk about why I'm not putting 10 in yet, okay? We're going to talk about that. So that's not, it didn't look that nice and neat to me. Okay, so we got to come up with the missing factors. So we do this, we fill in the blank one at a time. We're going to fill in this blank because we have, for the area model, we have its product and one of its factors. And so the missing factor here must be x squared. Once we have that, we can then do our multiplication and fill in this box below. We know this is negative 2x squared. And that helps us because we need that piece of the puzzle, because we know that since this is a diagonal here, there's going to be another like term up here that is going to, and these two terms are going to have to make 20x squared. So those terms are going to have to make, let me get my green highlighter out here. Those terms are going to have to make 20x squared. Okay. And so if I have minus 2, negative 20x squared, then I need a negative 18x squared to make negative 20. So this is going to make our negative 20x squared. That makes that second term. And then we start the process all over again, which should sound familiar, right? Because I kept saying that when we did our long division. Then we start the process all over again. I have this box, and that's a product, and it's 3x times something. So that something, I got to make negative 18, so I must need a negative 6 and an x. And now that I have that part of the factor, I can multiply that times negative 2 to get the bottom box. So I have a positive 12x there. And then I'm running out of colors. Let's see here, what can I choose? I think I'll do purple. So I know now that these two boxes are like terms. And so between these two boxes, I've got to make that x term in my product, which is right here. So I've got to make a negative 3x. Well, I've got positive 12. I've got positive 12. And I need a number here so that the result is negative 3. And so that means this missing fill in the blank is a negative value, because I need to have a negative result, negative 15. I need three more than this, but negative, because I need to make a negative value. And then the process starts all over again. Now I have this box here, and I have 3x, and I know I need to make negative 15x. So that means this has got to be negative 5. Okay, now I can fill in my last box. So now I'm coming back to this question. I'm really running out of colors here. How about orange? Now I'm coming back to this question here. I said I didn't put in 10 yet. So now I do this last multiplication. Negative 5 times negative 2, that is definitely positive 10, which is my last term. All right, that is this term right here. And the reason why I didn't fill it in right away is because sometimes that doesn't work out. When it works out, and we get this same last term as in our product, then we know we have no remainder. Okay? So we have no remainder because we got that value of 10. It divided out nice and neatly, which means that we know that this answer here for the missing product is x squared minus 6x minus 5. So we know that that is the missing product. Notice a couple of things. The degree is reduced by 1. Okay, because this factor has a degree of 1, so it takes away a degree from each one of these terms. So if we kind of try to summarize this as our learning targets, we're working on a couple of things. Oh, and I have some more vocabulary I guess I gotta talk about as well. Learning target number 1 is multiplying. Okay, so we use the area diagram. Use area or rectangle diagram. Okay, and when we use this, I'll just generically draw something that is 3 by 2. We know that we have our factors on the outside, and we have our product on the inside. Okay. And when we talk about the reverse or the inverse process, they call this learning targets 2 and 3. I'm not quite sure why, but they do. When we look at the dividing polynomials, we talk about reversing. This is an inverse process. And we talk about reversing the area model. And we also talk about, I'm going to do just a generic 2 by 3 again. That's probably the most common thing we're going to run into. We talk about whether or not this constant term or this, I'll call it the last term. I guess it doesn't necessarily have to be a constant. This constant term matches the product. All right, we talked about holding off of putting that constant term in there and seeing how the area model shakes out, and then checking to see if it matches. And if we have a match, if we have a match, then we have no remainder. I ran out of space, rats. There we go. And if we have no match, we have a remainder. So what does that look like when we don't have a match? And 1 and 2 matches and there's no remainder, but 3 is going to be that scenario where we have a remainder. So we're going to do this check your understanding number 3 together. So here is my, here is my product. Here is one of my factors. And we're trying to find the other factor. And then we're asking, does it divide evenly? Right? In other words, how about does the last box match? That's really what it is asking. Okay, so let's set up the area model here. So 1, 2, 3, 4 by 2 it looks like we need. So we need a little bit longer box. We need a 4 by 2 box. No, I take that back. We don't need a 4 by 2 box. Get rid of that. I should have looked at the degree more so than the number of terms. We have a 3rd degree polynomial, and we're dividing it by a 1st degree polynomial, which means we will have a quadratic as our answer, right? It reduces power by 1. So a quadratic is at most 3 terms. So we should need at most 3 across. Okay, so this is x minus 3. And I'm going to color code that orange because that's what my factors I color coded as. And then we have this this product, right? X cubed minus 13x squared plus 40x plus 14. So we start out by putting x cubed here. We know that that first term is not a simplified term, it just stands by itself. Okay, so that means that this has to be x squared up here, because that's what makes x times x squared x cubed. And so now it allows us to fill in this bottom box here. So this bottom box is minus 3x squared, but this is going to combine with this box because those are going to be like terms. And we know we need to make minus 13x squared. We need to make this x squared term in the product. So if we need to make a minus 13x squared, this must be a minus, oops, let me change back to product color. This needs to be minus 10x squared. And so I always like to back check. This plus this equals this. So yep, this has got to be negative 10x squared. I always work it backwards because I'm more comfortable working that backwards. So now that allows me to fill in this spot up here for the next term in my factor. So x times what is negative 10x squared. So I know I need a negative 10, and I also need another power of x. And so if that's the case, then negative 10x times 3, so negative 10x times negative 3, excuse me, misspoke there, is a positive 30x. You could put a plus sign there if you wanted to. And then go to purple here. Now we know that's a diagonal term, so it's going to have a like term up here, and together those terms are going to make 40x. So that means that this term up here in the upper right needs to be 10x. And then that means the last term in the factor needs to be a number that when multiplied by x gives us 10x. So this needs to be plus 10. And then we notice that as we complete that last box, we have 10. This has got to be a 10 to make this a 10x. So we got 10 times negative 3. That's negative 30. And that has to match our last term, and it doesn't. I'm trying to figure out what color to use. I'll use brown. This has to match our last term, and it doesn't. Our last term is 14. Well, negative 30 is 44 less than 14, which means our remainder, I'm going to highlight this because this is where we get our remainder. 44 less than means I have to subtract 44, and I'll stick with brown. I have to subtract 44 from my product in order to get down to negative 30. So in other words, in order for this to work out to be no remainder, this would have to be negative 30. And it's not, it's a positive 14. So I have to subtract 44 from this to get down to negative 30. So that's what my remainder ends up being. So so I have a remainder here. It's kind of off to the side here. It's kind of like if I took 15 and I divided it by 4. We know it goes in 3 times, and then my remainder is 3. So we would write it like this. Or we would write it like, let me erase that. Sometimes we would write it like this. 3 3/4, right? We put it over the 4, which is called the divisor. So my my answer then, my factor is, just coming back to blue here, is, oh, it's a factor, it's orange, is x squared minus 10x plus 10 minus 44 over x minus 3. So that is my, my factor. Does it divide evenly? Nope. It does not divide evenly. There is a remainder. And we represent that remainder as a fraction, just like we do here when we do our long division with dealing with just numbers. Okay, so the coming away from this section then is we're using our old area model that we've used before, and we're running it backwards in order to do some division of polynomials. And so as you're looking at the homework then, notice it starts out with, now this is where you have to notice the notation so that you're not doing the wrong process. This is multiplying. This is using our area model to multiply. And then this is all division. Okay, so this is using our area model backwards to fill in the blanks to see whether or not we have a remainder, basically. And notice that I say specifically number 5 and number 6 have remainders. The rest do not. Okay, so expect to have to express 5 and 6 with a remainder. So as you're working on this, if you want to work on the rest of the check your understanding, you can check your work on those in black.